Good. Welcome to our R tutorial class, and today we are going to introduce a new project. My name is Edwin Nyakan and I'm your host. The project that we're going to look at is TB HIV project. That's our title there, the one that I've highlighted, as you can see. That's our title. Before we continue with our project, we need to load some library. We're going to load two libraries, that is for reading Excel file and tidyverse. Then we're going to change the directory, our folders, using the function set working directory, and this is the path. This one here is the path of where we've stored our file. So highlight it and execute it. As you can see down here on our console window, here, you can see that it has executed successfully. If you want to see that these changes have been executed successfully, what you need to do is to execute get working directory. When you execute that line, you see that on our console window, the file, the folder that will be working from is called TB_HIV project. If you want to see the files that are inside our folder, you use the function dir. So this dir will tell you the number of files that are inside our folder. First thing first is importing data. Before you perform any analysis, we want to import data. And on our environment window, if I can zoom it out, you see our environment window right now, it is empty. It has nothing. But now we want to create an object called df, and inside this object we want to store the file that is called tb data using r.xls. When you execute that, there's a problem so with the naming, I assume. So let's check what is there. So the file that we want to import is called tb data using r.xls. And if we go to load those live packages, so I've just loaded the packages. Then when you execute that on our environment window now, you see we have an object called df that we've just created. When I double click on this object, it opens an Excel-like table, and this is our table. It has 15 variables of 53,379 observations. So here we have a county, we have years, we have quarter, sector, is patient prisoner, sex, age, weight, height, type of tuberculosis, type of patient, baseline smear. The other one we have HIV status, is the patient on ART, and also treatment outcome. So now that we are familiar with our data, we need to continue and see what you're going to do next. So with that, that's how you import Excel file using the function read_xlsx, then the name of the file, because we've just changed the directory. Next is to explore our data, and you can explore the data using different functions. There is str, glimpse, view, head, or tail. str will just tell you the structure of your data set. It will tell you the structure or the data types that are inside your data set. So for instance, this is a table. It's not a table, it's a table. And it has this number of observations. That is, those are the cases, 53,379. and 15 variables that we've just counted. Then our first variable is county, and county is a character. Our next variable is year, and year is a number. The same you can use the function glimpse. You can execute glimpse. You highlight and you execute glimpse. And you see also glimpse will give you the same output. They will give you the same output. As you can see, our data df, it has 53,379 rows with columns. Those are the variables, 15 variables. And these variables, these are character, these are quantitative, then the rest are character. Of interest is it has documented age as character. It has also input weight as character and height as character. And we'd like to know the reason as to why age, weight, and height, it has imported them as a character. So for that, I minimize the console window and I go to my DF. And you can see now in our age variable, it is alphanumeric. You see the age variable here, it is alphanumeric. It has a number and also an alphabet. And that's why it has imported this as a character. When you come to your weight variable, you see that weight, instead of having a blank, it has the word missing. So all these will be characters, and the same applies to height as well. It has text or a word missing, and that's why these three are supposed to be numeric or quantitative variables, but they are not. So that's how they were imported. Now that we know how to explore, the next now is to manipulate our data, to perform some of data manipulation or data cleaning. The first is to convert the string variable to a factor. So that's the first assignment. And how do you do it? First of all, we want to see the levels that are inside our treatment outcome variable. So I highlight these two lines and I execute. And as you can see, our outcome variable has 8 levels. C for cured, died, failed, lost to follow-up, moved to category 4 register, not complete, treatment complete, and this one, transfer out. So NC stands for those patients who are still on treatment. So we know the levels that are there. Now, how do you convert them into a factor? Again, we use DF, then we say treatment outcome as dot factor. As you can see, all levels, there's no typo mistakes, there's no spelling mistakes. So this one we can convert directly to a factor. And to convert directly to a factor, we use this function here, df $, then the variable. Then we use this sign less than minus sign. This one is create for me. Create for me a new variable called treatment outcome. Replace the value that are inside treatment outcome as factor. Use the function factor for conversion, then the name of the variable. So when you highlight this line, you see that it has executed successfully. So previously, it was a character, as you can see on our console window where I've highlighted, it was a character. But if you want to see the structure right now, will it be a character still? So let's highlight our script number 29 and execute it. And you see now, it is a factor variable with 8 levels. And these levels, it starts with, our reference level is cured, died, failed, lost to follow-up, and so forth, and so on. So it continues up to transfer out. So that's how you convert it into. Also, you can check the level. Instead of using structure, you can check the level using the function levels. Using the function level, when you execute that, it will give you the first level, which is our reference level, cured, died, failed, lost to follow-up, moved to category 4, on treatment, treatment complete, and transferred out. So that's how you check the level. The next manipulation is creating new variables. So from treatment outcome, we want to create another variable called RX categorization. So this is treatment categorization in short. So we replace the existing object, the DF. So we say create for me DF, replace the DF, then get for me the data. The data should come from the object DF that we had created. Then mutate. Mutate is the function that we use to create mutate. a new variable called rx underscore cat equals to case when treatment outcome is exactly equals to C, then we'll say that is a successful treatment. So that's why we use double equal sign to exactly equal to C or the same as C, then it will indicate that as a treatment successful or successful. Then also when treatment outcome is exactly equals to TC, then indicate successful, because keyword and treatment complete are the same. Those are successful treatments. Then when treatment outcome is exactly equals to NC, so this is not complete, then indicate for me on treatment. Then we say true. If the above condition, if we have any condition that has not been mentioned above, then those are failed. For example, when you go to our console window, you'll see that the failed treatments are F, the fail itself, lost to follow-up. These are patients who have defaulted their treatment. Moved to category 4, these are multi-drug resistance patients. They were started on category 1 and 2, and yet there was no response. So they were moved to category 4 because they failed and transferred out. So WHO defined unsuccessful treatment as failed, lost to follow-up, moved to category 4, and transferred out. And that's why we are saying anything that has not been mentioned among the three groups, then it should be considered as failed treatment. So this one, when we execute this, you can see it has executed successfully. Then when we open our DF, when you open our data frame, you see we have on the last column, we have a new variable that has been created, and it is called rxcat. That is categorization. Later on, we'll look at how to label this. So this is treatment categorization. And you can see on treatment outcome, which was our reference variable, treatment outcome, NC, it is on treatment. Anything that is on NC, it is on treatment. Then you see C, it is successful. So you see here where you have C, it is successful. Then if you scroll down where you'll get let's say, you'll get something like, you'll get TC, you'll see that TC is also successful. And again, if you scroll down further, and you have your NCs are here and not complete are on treatment. So that's how you create a new variable using the function mutate. And if this now we've created an ordinal or nominal variable. Now, another one is to another thing that you want to do is converting alphanumeric variables to numeric variables. And here you see alphanumerics are variables that have alphabets and numbers. They are combined together. So it has two steps of cleaning it. One is to truncate, that is to remove an empty space, because as you can see, we go to our data back again. You see our data here, age, this age here is 49. So we need to remove Y. But funnily enough, you'll see that our age variable also, you'll see that our age variable, it has also sum with months. Like the one row 26,318, it has also sum in months, and these spaces here. So first of all, we want to cut, we want to truncate, we want to remove months. And you can see this one is 0 years and 11 months. And when you are reporting these in terms of months, we'll just say it's anything that is, we truncate when it comes to years. We truncate, so we are going to truncate this one. So that's the first step. Then the second one will be, the second step is this one now. We say converting character variable to numeric. One, we remove the characters, the string. So here we'll create, first we create, define, df is our data frame, our object. Then we'll say df $ new underscore age. Then sub, use the function sub, bracket, quotation mark, space, dot, asterisk, quotation mark, comma, then blank, then the variable that is being affected. So this is our reference variable. If you go to, again, back to our data frame, you'll see this is the variable, our reference variable, the one that we want to build from. So when you execute this section here, when you execute number 14, you will see that there's a new variable that has been created. This variable, a new age has been created. When you go to our data, there's this variable, it has been created. And as you can see, there are those that had like months and years, for example, row 57. And when you come here, it's now 0y. Now the next thing is to remove the y's and make these to be numeric variable. Or what you can do, we can also look at now, we can glimpse and see if this variable, if the variable, what is the variable type of the new age that we've just created, this new age. When you glimpse, and you see now, when you glimpse, it's a character. And that means we can't perform any analysis using this particular variable. So what you're supposed to do is now to change it to numeric. And we change it with the numeric using the function as.numeric. Remember, it has a string. So we need to replace that string. So we need to remove that string. And that's why we are using this function string underscore replace df new age, comma, then square bracket, number between 0 to 9, then close, and then blank. So when we execute this section here, a new variable has been created. As you can see in our df, there's this new age. There's a variable called new age. So I can push it this side for you to view it. There's a variable at the end here. There's this variable that is called new age that we've just created. And is that new age a character or a string? We use the function script 53. When you do the str, you see now we've removed the y's. It was a character here, the section that I've just highlighted. That was the first step. But now after running the as.numeric str underscore replace, we have it as now numeric. And we continue we do our data cleaning. This is part of data manipulation, and we'll spend a lot of time. Now, how do you convert a string numeric to numeric? That's how you convert a string numeric to numeric. So if you have direct, let's say for instance, it did not have any, it was not alphanumeric but string numeric, we will use the function direct. We will not use str underscore replace. Correcting typo errors. So it's important also we learn how to correct typo errors. So for instance, you can use the function column names. So these column names will give you the list of the variables, the names of the variables that is in your data set. And in our data set, we have country and all these variables. Now, we want to look at the levels that are there inside our sex variable. So execute that. And you can see our sex variable is a character. Then the integers that are there are different. So for instance, here we have F, and the number of Fs are 19,186. We have female, 167. We have M, 33,817, and males. And you realize F and females are the same. So we need to change this female to be F. So these are typo errors that occurred during data entry. So we want to change it. Also, the same happened to M. Instead of typing M, some data clerk decided to type male. So we want to change this male to M. How do you do it? You use the function if else. So we use mutate and if else to replace male with M and female with and female with F. So here should be F and female with F. So you see here again, first of all we'll create a new variable called gender, and we are saying if else sex is exactly equals to male, then indicate M. If else sex is exactly equals to female, then indicate F. So the number of males will be added to M, the number of females will be added to F. Then here we say that since we'll use it for analysis, we again mutate, that is replace the character, because it was a character, with a factor variable. So we highlight all these and execute. And when you go to our df here and you scroll to the right, you'll see that we have a new variable called gender. And all gender are right now males and females. And again, we can come to see if that is correct. We come and replace this function here. Instead of having sex, we have gender. So when we highlight the two and we execute, you see now our gender variable is a factor with two levels, female and male. And these are, when you do the summation, you'll get a total of 53,379. So that's how you correct typo errors in your data. Now, what about, we've just looked at how to convert strings. So we have the county here. We want to convert county from numeric, because currently it's a string variable. You see, it's a character and it has 8 counties. So these are Kakamega, Kiambu, Kisumu, Machakos, Mombasa, Nairobi, Turkana, and Wajir with the respective numbers. So now we want to convert it to a character, a factor. You use the function mutate. So you say df, then percentage greater than percentage. We refer to that. Then mutate county as factor in bracket county. So when you execute that, then we can look at the structure. And you see it is a factor with, here on the console window, it is telling us, where I've just highlighted on the console window, it is telling us it's a factor with 8 levels. And these levels, the first one is Kakamega. So that's our reference level. What about the missing? Replacing the word missing. So when we go to our df, you'll see that like height, it has the word missing, and also in weight it has the word missing, and we want to replace this one with NA, because R only identify NA as missing value in a data set. So we use the function gsub. So we will use the function gsub. Then also, since it's a character, we'll change it to numeric. So again, this line we say df create an object called df, then use the object that we've created, then mutate height 1, gsub missing. So where there is missing, you replace with NA. And NA means missing value. Once you've done that, then you change it from character to a factor variable. So when you execute that, and you go to our df here, you'll see that now our height, we'll see that we've created a new object here at the end. It is called height 1. And where there was missing, for example, this one here, you see there's a missing here for height. But when you move the cursor, it has replaced it with NA, which means this is a blank. And also when you do the str for height, you'll see that it has changed it to numeric. So we can say str, then df $height, height 1 that we've just created, when you execute that line, it has changed it to a quantitative variable because we are going to use it to create another variable called body mass index or BMI. Here is just a repetition of how to convert numeric variables to factor. So here we don't want to delve much in it. So this one you can just execute and it will change all those variables to factor. On this assignment 3 that I issued, on this assignment 3 was to rename the levels in HIV status as follows. So we have different levels in HIV status. There is D. Remember, we can come here and say count. We want to count HIV status. So we want to count HIV status. So when you execute this one here, when you execute this one here, you see that we have ND negative and positive. And we want to change all those levels. So I did a mistake. So I need to execute all these that we've just done from here, from there, so that we can have our work. So when you do now, when you come here and say now, let's count HIV status, you'll see now we have D for declined, ND not done, neg for negative, and pos for positive. So we want to change all these. So we have declined, not done, negative. So how do you change that? So for you to change that, you use the function if else, the function that we had used previously. If else HIV status is exactly equals to ND, then that is declined. Alternatively, you can come say here now, if else. So let me just scroll a little bit so that you can see, I can fully see our screen. So you come here and see that now we have our NDs and everything is here, and you can see all these. Let me just make it move. That's good up to there. So here we say ND is declined, the D is declined, ND not done. Then if HIV status is equals to neg, then that's a negative. And the last one here, if HIV status equals to pos, then that should be a positive. As you can see, this should be a positive. So once you've done that, you come here also HIV status, and then we change it to a factor using line 115, using script 115. So when I highlight that and I execute, there's an object HIV status missing. So I need to remove this here. So I need to put a dollar. Then operator was missing. So I can do that. Then I come here and execute. And this, when you come to our new variable, when we do now, look at the levels. Look at the levels using syntax 117. You see now it has changed from D to declined. Our reference is declined, negative, not done, and positive. So that's how you convert that. The next thing that we want to do, how do you rename? How do you rename if you want to rename your variable? For example, we have a variable called here. We have a variable called here, HIV status, and we want to rename it to HIV. So how it works, first you start with the new name. So this is our new name. So we are telling R, rename for me the variable HIV status to HIV. So you start with the new name followed by the old name. So when you highlight this, you execute and you go to your data here. You come to your data, you'll see that it has changed it to HIV. You've changed it to HIV from HIV status. So that's how you rename That's how you